Going live. And we are live. Perfect. And it's almost 10. I guess we can ask how the weather is and then start everything. Well, okay, it's 10 p.m. It's a weird time, but hello everyone. It's XTechnologies. And today we have the code hour session. So usually we have it in the morning if you're in the European time zone, or during the night if you're somewhere in America. But today we decided to change it a bit. So now it's 10 p.m. in Middle Europe, and I don't know what time it is in the US, but so that's our experiment. And just a couple of words of who we are. XTechnologies, we're a group of people who are really excited about technologies, about IT in general, and we would like to learn more, to share our knowledge that we already have, and to explore new things and run different interesting projects. So today our format is called Code Hour. That means that we don't run like long-term projects, but it's basically something that we can present quite fast. Usually we try to keep it in an hour. So I think today it's going to be the same. And today we have a special guest. So it's the first time for Alexey. Alexey, welcome.
Thank you.
Yeah. So today Alexey will share his experience in computer vision or deep learning, image classification, and all the fancy stuff. So if you're about to start your adventure in this domain, to know something about the words TensorFlow, PyTorch, Python, deep learning, and so on. So that's the right time, and cool that you're joined, or maybe you're watching it in the future. Sounds cool. So I guess I will shut up now and give the floor to
Yeah,
Alexey.
it's a good time to give me a word. Hello guys, I'm Alexey. I'm a web developer actually, but I'm really passionate about machine learning and robotics, mathematics, physics, astronomy, and other stuff. And today I'm gonna show you a little project that I made myself. It's about creating your own images and then classifying them, training a convolutional neural network to classify them, and then running live predictions. So I actually think today I'm just going to create a few apps, an image generating app, like a simple paint, you might say. Yeah, it's going to be look like paint on Windows, if you remember. Well, and also I'm going to create another app that's going to show predictions, but predictions are going to be random for now, because I think in the next episode I can better explain like all kinds of neural networks and their types, and why some neural networks are good for image classification tasks and why some are bad eventually. We can also talk about different loss functions, I think, and other stuff. So don't mind me looking up from the camera, because my second monitor is actually my TV, and I see my stream like up above the camera. That's why I'm looking there. So right now I'm going to switch to my screen actually, and you're going to see my IDE. It's Visual Studio Code, and now we have a completely empty project. And I think let's just create a new file and call it painter dot y.
And Alexey, are you sharing the right screen in OBS? I mean,
yeah, I think I do. Can you see my like empty
yeah,
IDE
yeah,
right now?
right. Yeah, I just see it with a bit of delay. Exactly. Yeah.
Right.
Okay.
And let's import a few packages first. So first of all, let's import pygame, and let's import it as PG so that I don't have to write it as pygame for so many times. And actually, let's also import from pygame a few functions called display, time, event, and mouse. which we are going to use later on. Oh my god, no, don't autocomplete this, please. Yes, thank you. We are gonna also use a torch, and we are going to import the zeros and type called uint8. And also we have to import an exit function from system package so that we can exit our application later on. So it's I think that's it for the imports, and now we're just going to create our own class called painter. And let's define initialization for it. So just init. First of all, we have to initialize pygame so that we can run our application.
Alexey, may I just interrupt you for a bit? Could you maybe zoom it in a bit?
Oh, yeah. Sorry. Yeah. Of course I can. I forgot to do it.
Yeah, perfect. That's perfect.
Yeah. Also, let's set like a window name. It's done like this: display.set caption, and we are going to call it painter. We are not actually going to see this like window name because we are not going to use this this painter like as a standalone unit. We are going to like create other classes from it, but for the sake of sanity, let's set a caption that's going to define this Windows name. Also, let's set our size, window size. And it's going to be 640 by 640 pixels. So it's going to be an actual like window size that you're going to see on your screen. And then I also want to define grid size. Grid size is actually a grid of pixels. So I'm not going to, save a data for like 600 by 600 pixels large image and then try to classify it because it's it's going to take a long time, and I'm just going to use like a big window, but we are going to see only 64 pixels actually. So it's going to be like squares that we are going to see, but you're gonna witness it yourself later on. Also, let's set our grid right now. It's going to be PyTorch. I think PyTorch tensor. You've just imported zeros from Torch, and we're going to save our pixel values there. And for the beginning, we're just going to set it to zeros. So we are going to see black pixels. Actually, that's what we're going to see at the very beginning. And let's just path grid size so that it knows how many. So it knows the dimensions, and also pass a d type we're going to use. Also, right now we have to define pixels size. This is going to be like a size of a pixel, and you can actually calculate it yourself. We have like an actual window size here, and we have like how many pixels we have. So it is 640 divided by 64, and it's going to be 10 by 10. So actually our pixels will be rectangles of 10 by 10 pixels in our application. We can actually set it like this, but I prefer to like set it, from the calculation that we are going to write right now. Oops, sorry, where's my mouse? I also have hints up above, so it is easier for me to remember stuff. And let's go.
Just by the way, you don't have to do it by heart, but it's super cool.
What did you say? What did you say again?
I said you don't have to do it by heart, but it's super cool that you're doing it.
Oh, thank you. Yeah, I think next time I'm not going to write it all by myself. But let's go. So we have self size. So this is width of our window, and we're going to divide it by self.grid size 0, and the same goes for like height. So we can actually just copy it. I think it is easy to follow. We're going to just change this index. All right, so far we've defined size, grid and pixel size, and what we also need is frames per second that our application is going to be run at. I'm going to say that well, I think 480 is fine. What else do we need? We also need a screen that we are going to render our items on. Let's define this. We are going to write display dot set mode, and we are going to pass as an argument our size, so window size. So now we have a screen, FPS, pixel size, grid size, and size. We also need the last and yeah, the last thing, and it is clock. Clock is needed for pygame applications to, you know, to pass time forward. All right, this is it for our initialization. And what can we do right now? Let's actually define our start function. So it's going to be the main functions that we are going to run. And while true, so run this loop like forever. This is how you do it nowadays. Right now we don't draw anything on the screen, and we have to do it. So let's create a method called well, I think we can just call it draw stuff. So this method is going to draw like our grid of pixels and any other items that we might want to display later on. It's going to what are we going to do? So we have to draw our grid of pixels, and we can do it like this for I and row in enumerate self.grid. This is taken well, eventually right now our grid is 64 by 64 tensor, and we're just taking one row at a time in this loop. I is our index, our I is our index, and row is actually like a row of an array of 64 pixels. And we also need to not only cycle rows, but we also need to cycle columns, and we do it like this. We call the second index J for some reason, and
Magical.
Yeah, for some magical reason. And we also in this array of 64 pixels we have like some values. Right now they are all 0 because we define them as zeros in this function right here. But it is going to be a white value for the pixel, white value. So it's going to be between 0 and 255 eventually. In enumerate row. And right now we have to render this pixel. We're going to define a color. We have a grayscale. We are going to have a grayscale image at the end. Actually, it's not really grayscale because we can only have black or white pixels, but it is called grayscale nonetheless. So let's write our color will be like this. So we're just going to, well, eventually white value is 0 or 255, so it's either black or white. And then we are going to define a rectangle that we are going to draw in our window application. We have to actually I want to define dimensions, like the starting position for this rectangle, starting position for the like x value, y value, and how much pixels wide they're going to be. So let's oh, actually I have it right here. I can actually copy this so that I don't have to write it, and then I can explain it to you. So here we have like j. J is an index for the column. It's going to be multiplied by pixel size 0, and eventually it's just going to take us to the starting position of this pixel in our application. Same goes for the row, and this just define like how many pixels wide our rectangle is going to be. Now that we've defined it, we have to draw it, and for that we use pg draw rectangle. We're going to render it on our screen. We are going to render it in this color, and we're going to render it at this position. So let's just try it out, I guess. Well, true. Draw stuff. Oh, it's actually self-draw stuff. Let's try to run it. Python. Oh, actually, we've just defined the class, so we have to create an entity of this class and start it. So let's call it painter. My painter. Oh. All right, let's see how it goes. Yes. Painter.py. All right, we have a window. It's called Painter. I think you cannot see it pretty well, but I see it myself. Just believe me, it's called Painter. And right now it is like completely black, but it is because we have zeros for our pixel values. So let's actually exit and oh my god, it's not exiting. It's because I haven't defined a system exit function. When I press like this red close button in our application. Let's actually do this first so that we don't have to terminate this application like this. Or you know what? I can actually terminate it one more time and just show you how like complete white screen is going to look like. For that, I need to. I think I can just self-read equals no, that's not great. How do I set a value for every tensor? You know what? I'm not actually sure. So let's not reinvent the wheel and just first of all create.
I think you can maybe initialize it as np once or
yeah, we can do it as once, like that's the wrong import. You can actually just import torch and have torch once, but it's not going to look very different because there is so little difference between 0 and 1 in the range of 0 from 0 to 255, but you may notice some difference.
Yeah, but can you just multiply the whole tensor by 255?
Oh yeah, that's a good idea, Igor. Thank you.
Yeah. I think Python usually allows it, but I'm not sure. Oops.
Right. It's not showing anything. Come on.
I guess I had not the best idea.
No. First of all, maybe well, actually, I think it has to work like this. But let's first of all let's try to make our application exit easier. For that, we are going to get events from our application. It's going to it's going to take all our mouse events and keyboard events. It is done by events.get, and then we have to match. Oh no, actually, for every event in events, they're going to match event type, and in case it is pg.exit, pg.quit, we have to quit the application. Let's try this out. So right now we can easily exit the application if something goes wrong. So I just press this red button up here, and it's closed.
Perfect.
So what else we're going to do? Let's try to, we have to draw in this application. So let's define a draw function. Like, it's actually going to be a paint function, not draw, because we already have draw stuff function. So they have to be differently named so that we don't mess them. So in case our event type is mouse motion, pg mouse motion. So this event fires when I move my mouse inside the application. We are going to check whether our left mouse button is pressed, because we only want to paint when our left mouse button is pressed. We don't want to paint it all the time. So let's define left mouse button pressed. We are going to take this value from mouse get pressed, and this function is going to return 3 booleans. First boolean will be whether left mouse button is pressed or not. Second boolean will be whether middle mouse button is pressed or not, and the last one is for the right mouse button. And we need only first of these buttons, so we get this first element, and then we check if left mouse button is pressed. We are going to take position, mouse position, mouse get position, and then we are going to define any function called paint in our class, and it's going to take position, that we are going to pass position inside it. And let's actually define it right here near draw stuff method. It's going to be called paint. We're going to pass, first of all, we have to pass self, and then position, mouse position, but I'm going to call it, oh, actually, I'm just going to call it position as well. So right now we have like mouse position, X and Y values. So we have to extract this from this position. Then we have to identify in which column and row this mouse position is inside which row and column, so that we can draw this pixel, well, this rectangle white. Yeah, it's actually pixel size. So we divide mouse position x value, mouse positions x value by our pixel size, width for our pixel size, and we actually do integer division, because we don't want column or row to be like a real number. We want them to be like integers, so we can access them inside our grid. And let's do the same for the y value as well. It's going to be a simple copy paste. And then we just have to, grid row column, and we set it to 255. And let's actually go back, reset our grid to zeros in initialization function. And let's try it run. Oh, torch has no attribute 0. Oh, it's because it is not 0 but zeros. Come on, Painter. What's wrong? Why don't you launch?
It's almost there.
Let's examine the problem. Only integers, slices, ellipses, not long and long or byte variables are valid indices got float. I don't actually know why this happened. I'm not sure. Let's just print them out, I guess. Debug, very fast debug. And it's 25 and 24, but with dot. We don't want it to be dots. We don't want them to be reals. We want them to be integers. And I'm actually not sure why they are not integers. Let me check it above. What went wrong?
I think maybe this double divide operation, it doesn't return integer. Maybe it just returns the number, like it floors a number, but it doesn't convert the float to integer.
You might be correct, but let me check it nevertheless. So what we have initialization pg init display set caption, painter self size, we have grid size, we have grid of zeros, dtype uint 8 pixel size. Actually, you know what? This happens because we have pixel size as reals, not integers. So right here, you can see we divide x, which is real, which is an integer, by this value right here. But this value right here is not an integer. It is a float. Yeah, and I think we can easily fix it and just add a few dashes right here, so that right now pixel size are integers. Let's try this out. All right. Yeah. Now they're all integers. Fine. That's cool. Why doesn't our screen display anything? That's the question, because you've seen nothing is displayed. Actually, it's right here. It's pinch black right now for some reason, but it's not doing anything when I click my mouse button and move it. So this is another bug that we have to fix. Let's actually try it one more time. And I think something is wrong.
So we every time we change the self.grid, right? So self.grid should be drawn. Or
by the way, it should look like this. I'm just checking.
Yeah.
I'm not sure what went wrong, to be honest. Oh, maybe, you see, we haven't completed our start function. While true, we draw stuff and like do something with events, but we don't pass time forward. Yeah, for this we have to, update our display first. Display.update in pygame, and then we have to, tick our clock. Yeah.
Shouldn't it be a bit to the right?
Yeah, you're correct.
Yeah.
Right here. And let's try to run it. And yeah, look, we can draw right now. Great stuff. But you see, this line is too thin for my for my preferences. So I'm just going to add a few more pixels. Well, what I'm going to do is just increase the thickness of the line by drawing rectangle wide if it's near our mouse position. So right now we only draw one rectangle wide, but let's draw a few more. For example, this pixel right here, and this pixel right here. So right now we update not a single pixel, but 3 of them at the same time, and it's going to, yeah, this line is now more thicker, you can say.
Beautiful.
All right, it's good. It looks good. What else? What else do we need? We need to somehow, completely erase the picture. For example, I don't want a 3. I want something else, and I just, I cannot erase it right now. I want to erase it, but I can't. And for that, we can define another function. It's going to be called clear canvas. I believe it's a good name, clear canvas. Or clear screen as well is good name, but let's stick with clear canvas. And this function is actually easy to write because we can do it like this. We are going to update grid indices. Every grid index that is not 0 is going to be 0, and we are just going to do it like this. Self grid doesn't equal 0 equals 0. Or we can just do it another way, more simpler way. We can just say self grid equals zeros, and just pass our grid size and d type. I guess it's going to work the same. So let's try these two ways of doing it. Oh no, we've defined this method, but we don't actually call it anywhere, so we're not going to check it.
Maybe it will work itself.
Let's call this method when we click right mouse button. With the left mouse button we draw, and with the right mouse button click we will clear the image, the screen. And for that, let's get back to our cases. And in case it is pg dot mouse button down, here it is. Then we have to match it by actually mouse button that we've just clicked. So match by e dot button. And in case it is 3 stands for left mouse button, we just I guess just self dot clear canvas. Oh, okay, clear canvas. And now it should be okay. Let's go. Let's draw 3, and let's click right mouse button. Yo, it's pinch black once again. All right, now we can draw. Now we can clear. Oh, actually, let's try out this method that I wrote for the first time, and it also works. But let's stick with this one because it is easier to understand.
Alexey, you just implemented the basic functionality of Tint in half an hour. That's super impressive.
Yeah, we could add a few brushes as well, a few colors, but it's not what we are going for. So this is fine for our needs. What else do I want to do with this painter? Actually, I think that's it. Yeah, we can draw, we can clear, we can get our pixels values. All right, that's it. So we've defined painter class. Let's also define, well, our image generator, because in this painter we don't like save images, we don't create directories, you know, we don't label images, but we want to do it. For that, I will create another file called, I guess, image generator.py is a good one, and I'm going to instantly import our painter here. Igor, are you here?
Yep.
Sorry, it's just some kind of, you know, some kind of trouble that I had with the headphones, I think. Right now we've imported painter, and we're going to modify it a bit. So what are we going to do? Let's actually, you know, I also can copy paste it right here. We do also import, for that, let's delete this. We also import pygame, we import phone, display, event, and mouse from pygame as well. We import exit, exactly the same as for painter, but we also import this module called pygame text input, because I don't want to create my own text input to, you know, write words, write labels in our case. So this is like an independent package that you can use. It's really good. So you know, you should install it first, and then you can use it. I do also import from OS makeDirs and listdir methods that I'm going to use, and I also import from OS path a few methods called exists and join, and rename them as exists path and join path. So let's create another class. Let's create a class called image generator. This time, generator, and it's going to be created from the class painter. So painter is going to be a parent for this class, and let's define initialization function for it. First of all, I have to, you know, initialize our parent. Right. So what we have right now is, you know, if we just run, if you create an instance of this class called my image generator, and start it, it's going to be the same as a painter. Image generator. Yeah, you know, it's called painter as well in this window. We can clear, we can draw, but we now want to modify it a bit. So first of all, I want fonts to exist in our image generator application, because I'm going to type labels for images that I create, and for that I initialize fonts from pygame, and I also do not here text font. I do also define our text font, which is going to be Comic Sans, and it's going to be a bit, I mean, it's going to be not that large, but not small, so that we can see it. And also let's rename our application window name. Application's window name, it's going to be called image generator this time. Display set caption image generator. What else do we need? We do also need an input for this application. Let's define it. Self.input equals text input visualizer that we've just imported from this package right here. And we're going to pass a few variables here. Font color is going to be white. Oh, it's going to be red actually. I want like our input to be red because I can, I don't mix it with our drawings. You're going to see it pretty soon, and I want our cursor color to be red as well. 0, 0. Well, actually, I think that's it for now. Let's actually draw this text input that we've just created. So we have to redefine our function called draw stuff. Oh, wow, autocomplete is just great. So
Yeah. Just cool stuff, yeah.
I've just pressed enter and it's complete. So in this function we call our parents function, our parents method, and well, we call it, but I don't want only it to be run. I also want our input to be, to be created, to be displayed in our screen. So we make it like this: self.screen.blit. Self input dot surface. So this is the surface that we are going to draw on, paint on, and I have to also define a position for this input. I think 1010 is a great position for it. What else do we need? We do also need actually, I think this is it. We now display input and we can draw. So let's try this out. Yeah, I think we just try it out. We don't input right here. This is bad. So let's see what went wrong. Self-screen.blit. So input the surface screen.blit. I'm not really sure. Let me.
Where did we define screen? Sorry, I think I missed it.
Screen is defined inside Painter, and it is a parent for our image
okay,
generator.
it's explicit mode. Okay. Yeah.
Text is. All right, let's return to it later. Let's also add a text that displays how many images with this exact label in our directory. So I'm just going to describe it a bit better so that you understand what I'm going to do. Now we have this painter, and we can paint some images, but we don't save them. I want to save them and then use later on. I want to feed them to our neural network that we are going to create as well. Right now we don't have a method to save the image that we've just drawn. We can draw it and we can erase it. That's bad. So let's create a method to save them actually to some directory. For that, I'm going to define a new method called save image. And what I'm going to do here, first of all, I'm going to. Oh, and you know what? How our images are going to be called? Well, in our system. So I think we can, what I propose is to create a directory called created images, and inside it we should have a few folders, and first one is going to be called, for example, let's call it square, and inside this directory we have to save squares that we've just drawn. So I think we can just name it, in ascending order. So first image is going to be called 0.png, second image is going to be called 1.png, and so on. And for that we need count. Actually, we have to save count somewhere for this for these images. And I'm going to create a new variable called count right here in our initialization function. Count equals 0. So by default it should be 0 when we run the application. And what I also want is to define a variable called current directory. I'm just going to simplify it to car.dir, underscore dir. And it is going to save the label of our images. So for example, if we painting ones or squares, this value is going to be 1 or square eventually. When the application starts, it's just going to be empty. What else do we need actually? I think this is it for now. Let's define our method. File name is going to be count. JavaScript count, and the extension will be PNG. I cannot use JPEG or other formats that compress data with the losses, because then it's going to be really hard to feed them to our neural network. I mean, it would be possible, but the end result will be not as good as if we saved it in PNG format. Also, let's define a path that we are going to save to. Join path. And we're going just put current dir and file name together, and it's going to be actually our save location for this image. And also we need to have like image pixels in some format that, well, we have like a grid, 64 by 64 pixels. It is a tensor from PyTorch right now, but to save, we cannot actually save it. We have to transform it to some other, I think, entity, and for that we can use a great method from Torch Vision. So from Torch Vision, dot transforms. I don't have Torch Vision installed. This is not correct. I should have installed it. Maybe I wrote it wrong. No. Do I not have it installed? Let me check it real quick. So install. No, I do have it installed, so it's something wrong with the linter. Strange. Is it though? Never mind. Let's move on, and we have to create this transformation. So to image transform. Oh my god, where am I? To build image. And I'm going to use it right here down below. and I'm going to pass it our tensor. It is self.grade. And then I'm going to save it, so image.save, and save it to this destination. And then I'm going to update our count because we've just added an image. All right, have this method, but we don't call it anywhere. And let's actually think about how do we call it? Well, where do we call it? I think
We still have some buttons in the mouse.
yeah, we have one mouse button remain. It is middle mouse button actually. So what I want to do is when I press middle mouse button, this image that is currently displayed in our application is going to be saved to our directory that we've defined. For that, I need to redefine our start function actually, because it doesn't look like this anymore. We still have like mouse motion, mouse button events, but we do also need another mouse button event, and if event.button matches 2 is the middle mouse button. I'm going to, first of all, I'm going to save an image, so self.save image, and then I'm going to clear the canvas because, well, if I have already saved an image, I don't really, want to make changes to it. I just want it to be completely black again. So self.clear canvas. So if you run it right now, we have our directory set as empty, but let's actually, call it something. Let's, for the sake of testing, let's call it created images, actually. Created images. Our count is 0. I think you can actually try it. I hope this works. I mean, this time it should. So let's create 3. Wow. All right, let's debug. No such file or directory created images 0.png. Oh, we have to create this directory as well. I wonder whether we can, create it when we save the image. So I think we can.
We can check whether it exists and
create it if create it if it doesn't exist. Let's.
But maybe it's faster if you just create it for the sake.
Yeah, for the sake of testing, I can just create images. Oh my god, let's clear this mess. All right, something happened. I pressed middle mouse button and
yay.
Wow, 3 is here. All right, can I draw something else? All right, I drew 4. Oh, here it is. All right, finally, and they are called 0 and 1. I hope you can see them. Yeah, you can see them. All right, so now I can create images, but I want them to be saved in according to their label. So I have this 3 and 4 together in one directory, but later on when I try to import them, how do I define myself? Well, not myself, but how do application define whether it is a 3 or 4 if it if no neural network is present yet? So for that, I think we can just create a label directory inside created images. Well, I've described it already, and for that what we need is some way to change directory, well, change the label of directory that we are going to save our images to. let's for that let's define a change directory method. Change directory. All right. It's going to change our current variable. Join path, and we have a directory called created images, create images, and then we have to join an input value, but we don't have input yet. It was broken. So self.input.value. So what I want to do is to have an input in our application, and we can write something in this input, and it's going to be a label for our directory. But we don't have input displayed yet. So we have to debug this. So why does not a input show up in our application? That's a good question.
The easiest way maybe is to compare it to your already working version.
Yeah, we actually can just run to check whether it works there first. So this. All right, so it should look like this. We should have count right here, but we are going to create it later. And we have input here, and we can type something in this input. For example, a square. Oh my god, I spelled it wrong. Square, or 1 or 2. I'm just going to look through my code right here and see where my code differs. Let's try this out. Still don't have input show up. This is not good. Input text input visualizer cursor color font color. Text font. Do I have text font right here? I do have it. So input. Input surface.
I don't know, Alexey, what do you think? Maybe it's a good moment to make a pause.
Oh wow! Oh, an hour already passed. Wow, it was a quick hour indeed. So I think I mean it is a good place to stop, because right now I want to debug everything and see why doesn't my input work. So next time we can continue trying to display our input, and then we can create another application and move on to our neural network discussion. Neural networks discussion. I think it's going to be two more sessions. I think one more would not be enough.
Yeah, it's pretty fruitful. Yeah, that is cool.
All right, Igor, thank you for helping me out in this difficult times.
Sure, no worries. I mean, really, what you just did, you implemented basically Paint, which is super cool, in an hour, or actually less.
Yeah, I wanted
yeah.
I wanted to make much more stuff, but not this time.
Yeah, and just a question from me. So you're using this PyGames, right?
Yeah, it is pygame.
Pygame, yeah. So that's the library for visualization and building games, or?
Yeah, it's actually just a Python library, Python package for making like simple games. You don't actually you don't create like some AAA games in this program. So it's just just to test things out and maybe create some simple application, but nothing like huge.
Yeah. Oh, Yeah, but it's pretty functional. Yeah, I didn't use it before. Good to know.
Yeah,
Thank you
so
for showing.
I think Igor can say like some final words, and we can just
Yeah,
stop the
sure.
stream.
Yeah, yeah. So once again, thanks, Alexey, and for showing us for going through all this stuff live. Actually, it was pretty impressive. And thanks everyone who was watching, who is watching, or who will be watching. And we will be back, I guess, maybe next week or maybe in some time. And Alexey will finish his project, and we will have a super fancy deep learning game or kind of.
Well, yeah, kind of.
Yeah. Yeah. Cool. Yeah. Now we should say like good night if you're somewhere in Europe, and maybe have a nice day for some other
Yeah. Good night,
parts of the
everyone.
world.
Bye
Yeah.
bye.
Cheers.